Hello, everybody. Welcome to another edition of Cloud Native Live. My name is Matthew Cassio. I'm your host for today. I work at American Red Cross by day. I'm a CNCF ambassador as well. We're happy to have you here where we dive into the cloud native code that powers all of your things. We're going to make things, we're going to break things, we're going to have fun today with Marvin and Simon from Kubernetes. You can see on your screen today's topic. I am not going to take much time. I'm going to hand it over to Marvin and Simon. Thank you for being here today. I will monitor chat, and these guys will explain as well, but they're very interested in making this interactive and dynamic, and they'll be addressing questions and comments throughout the talk today, and I'll monitor again chat and throw them up on screen so that everyone can see what we're talking about. So without further ado, Marvin and Simon, if you want to take it away, it's all yours.
Yeah, thanks for the introduction. Thanks for having us at CNCF CNL. Today we want to talk about CNCF project KCP, which is for Kubernetes-like control planes for declarative APIs, and we'll promise by the end of this webinar it will make sense to you what we mean with all these cryptic words chained together. Today I'm joined by Marvin, who is a team lead here at Kubernetes and a CNCF ambassador, and who's also the maintainer, or one of the maintainers for the KCP project. I'm Simon, I'm a software engineer at Kubernetes, and I also contribute to KCP. We wanted today to really have an interactive session for all of you, which means that it's two of us together, so one person always will be showing something on the screen. We will be doing lots of things in the terminal today, lots of things live, and we would really ask you to write any questions in the chat, and we will integrate them into today's session. And this also means we only have one slide prepared, and everything else will be then done live. And for the one slide is we thought it makes a lot of sense to talk about why we're doing the things that we're doing and why do we need yet another project to fulfill them. And we thought the best way to do it is to have like a red lining throughout today's webinar is to give you an insight into what it is that we're actually wanting to achieve. And what we're wanting to achieve is to build a multi-tenant API platform. And what we mean by this is, imagine the following situation. Within your company, you have provider teams that want to provide services to other teams. And typically, we've just chosen two examples. It could be a certificate team, and it could be a database team, and they want to provide these as a service to others. And by others, what we usually refer to them are consumers, and these, in our example, could be application teams that like to have a database or a certificate cluster. To have a certificate or a database cluster in our situation. And then in between sits this multi-tenant API platform, which we are going to explore in detail today. On a higher level, a general flow that could look like this is that we have a multi-tenant system, meaning each consumer can consume a service from each of the providers. And we both want flexibility to have this interaction and also to have some isolation, because obviously consumers from team A should not be able to see what consumers from team B are doing. And so in general, we think of this that we have consumer tenants and we have provider tenants, which are isolated from each other. And having this in place, a typical workflow would be that the provider teams, they decide to publish their APIs into their tenants to make them available with other teams. And then consumer teams can consume these APIs to make them usable. And then they would actually use these APIs. So in this example, for example, they decide databases are what we're interested in. So they create databases or they create certificates. And then there is some sort of mechanism that allows the providers to receive the order. And this is what this talk today is about, think that KCP can be a great solution for this use case. And this is something that we want to build together today within the webinar. But before we can dive straight into this, it makes a lot of sense to learn about some of the core concepts in KCP and how they interact with others. And for this, I hand over to Marvin.
All right. Hello, everyone, and welcome from me as well. So I'll basically dive right in, and I'm going to show you a little bit of what KCP is. We are going to talk a bit about the history and basically have a kind of look at what the project really is. If you can bring up my screen, then we'll start out with something that most of you probably have seen already. And that's the CNCF landscape. So like this is big. You probably can't read it. That's fine. Like you probably have seen this already. But the ecosystem is quite big, and a lot of it is integrated in some shape or form into Kubernetes. And if you have been around for maybe a longer period of time in the ecosystem, you might like know how long Kubernetes has this extensible API pattern. So it started out with TPRs, third-party resources, yes, TPRs, and eventually evolved into CRDs, like something that a lot of you probably are familiar with already. And a lot of that is actually, a lot of the tools that you see on the landscape here have some form of controller operator pattern implemented to integrate into the Kubernetes API. And we think that's a testament to how well this whole Kubernetes resource model, the way that the API works, really is. Like it's been a success story, like pretty early on from the ecosystem. And this whole success and this whole like ecosystem of APIs and API integrations that have been built around Kubernetes basically triggered this thought of, hey, what if the Kubernetes resource model can be used more than just as a container orchestration platform that has some API extensions that you can install? What if you start with an API platform first that speaks the same language as Kubernetes? And that's basically how KCP started. So the KCP project started out in 2021 as a research project, trying to basically decide on this idea of, hey, what can we do with Kubernetes resource model? What can we build on top of the Kubernetes code? Like there's a lot of code in the Kubernetes repository. A lot of it's like going into the kube API server, kube controller manager, like a lot of tooling, a lot of logic, and the Kubernetes resource model is like at the core of that. So the KCP project started 2021. It's been started, as I said, as a research project and eventually became community governed. In 2023, we brought the project into the CNCF, so it's in the sandbox now for around 2 years. And basically, the idea, as I said, is building a horizontally scalable control plane for Kubernetes-like APIs. That's kind of the core idea of KCP. And like, if we want to basically go one step further, what if you could do basically anything with Kubernetes-like APIs except manage containers? Because this is something important. Before the project got under community governance, it had like a wider scope. It was exploring something called transparent multi-cluster, short TMC. And eventually, when we focused it, we decided, okay, there are a lot of like multi-cluster like scheduling solution out there. Like if you look at the landscape, I think there are several that are under the CNCF as a project. So maybe that wasn't the core like value of KCP. Maybe it was more exploring this multi-tenant API platform part of it, and not this. Not necessarily this specific implementation or like usage of this API. But that means if you go and look for KCP content, sometimes they all transparent multi-cluster, and that is no longer a core focus of the project. So that sometimes to mention that real quick, because that's part of the project's history. So what does all of this mean? We wanted to get hands-on, and we're going to do that. So KCP has a getting started guide. We're going to basically click here real quick, but I can tell you already what that means. So KCP comes as a single binary. So that means you can either launch this in a container, and if you're deploying KCP in a production setup, you should definitely do that. Like, it should run in containers. Like, we have a Helm chart, like you can install KCP on top of Kubernetes quite easily. But basically, if we just wanted to get started, we can download that binary and start a KCP server on our local machine to just go and explore it. So I can tell you a bit about the different concepts that come with KCP. And we're going to do just that. So here, basically, all of this is what is needed to start a KCP server. So why don't we do that? I've prepared that already. So basically, I'm going to start KCP here. KCP is based on the Kubernetes API server and has very similar logic. So you see basically KCP bootstrapping itself here now. But what this basically means is that the single binary KCP that we're running here, that is kind of the development mode of KCP, and it includes an etcd as a data storage. So same as Kubernetes, KCP uses etcd to store its state. And it also includes a bunch of controllers. In Kube, you usually have the Kube API server and the Kube controller manager. All of that is currently running in the single KCP binary. So just that you have a mapping, if you've worked with Kubernetes before, this basically is. So we have KCP up and running now. This is how easy it was to start KCP for some exploring developer modes. It is not recommended to do this in production, but for us here, it will suffice. So let's jump right in. So I have a kube config that I've already prepared. This developer mode, what you get is an admin kube config that allows me to interact with KCP. And that is maybe the first part here, because I said earlier, like, it's a Kubernetes style API control plane. And that means it's compatible with clients that you're using. So if you're interacting with kubectl, maybe you're using other tools, like maybe some UIs, or maybe some CI/CD tooling, GitOps, all of these can interact with KCP because KCP speaks the same language as Kubernetes does, essentially. So that means with this, and I'm going to do this. So I will check for namespaces. That's a thing that exists in Kubernetes, right? And they also exist here. So I can see that there are some namespaces here, and yeah, that's cool. That means I can create some objects in those. I could also permissions to people that they can interact with specific namespaces. They probably have done with Kubernetes already. But I talked, or like we alluded a little bit to KCP having multi-tenancy features. And these multi-tenancy features in KCP go beyond what Kubernetes has to offer. And kind of in the spirit of namespaces, these are called workspaces. So think of them as a unit above namespaces. So basically something that holds multiple namespaces and that allows you to isolate different, let's say, groups of users, parts of your organizations, in short, tenants from each other. That's what multi-tenancy means. So there is an object type here, a resource that I can query that's called workspaces. And currently, there are no workspaces here because I haven't created any yet. But every KCP installation has something that is called the root workspace. So I am currently interacting with the root workspace of my KCP installation. And I will happily make this terminal a little larger for the chat. I hope this is better. But yeah, basically, this means I'm already talking to a workspace. And I can show you this. So the kube config that I'm interacting or that I'm using to interact with KCP will show you this by using, so if we can go all the way. So the current context here is the root context. This is a cluster called root, and that is this here. And you can see here, this is the URL that I'm talking to. And if you've dissected kubeconfigs before, you might have realized that often you like have a host name and a port in there, and that's it. Like mostly it's maybe something like API dots, I don't know, kubernetes.provider.com. Like if you're using a managed Kubernetes offering, those like often generate like long kind of randomized DNS names for their cluster endpoints. But you might not have seen a subpath on this, but it works. So what's happening here? We're talking to a specific, this is kind of a low-level concept, so we're not going to talk about it that much, but we're talking to something that KCP is calling a logical cluster. And a logical cluster means that it acts like a Kubernetes cluster, like the API endpoint of one distinct Kubernetes cluster, but it is not, because we're talking to a path of the URL that then basically is mapped by KCP to a specific, what we call logical cluster. That has a bunch of implications, because that means I can easily have a lot of these multi-tenancy units, like workspaces, to interact with, and each of them look cluster from the outside. So let's do this real quick. So let's create a workspace, because it will give me access to another logical cluster. And we're going to do this by using a kubectl plugin that is provided by KCP. There's information on that on the docs. I've already installed that. That is called Create Workspace. And we're going to create one here that we call Live. So now a new workspace has been created for me. And that means the following: I can see it now as an object here. So I see that there's a workspace. It is of a certain type. It's been marked as ready. And you can see here that there's a URL here. URL is the URL of the logical cluster. So that means if I talk to this URL, it will actually look like a different Kubernetes cluster to a client. It is not the same. Like we're talking to the same key, talking to the same port, to the same host name, or IP in this case. But KCP has intelligent routing under the hood. This is a different logical cluster, so that means the request needs to be served differently. And we can switch to this. So this is pretty easy to interact with. Think of workspaces being organized like a tree structure, kind of like a file system. Because this means, and this is another kubectl plugin that we've developed that helps us with, we can switch into that. So we can switch into Cloud Native Live. And now basically my terminal tells me that I am now in a different workspace. And I've switched the current workspace. So yeah. Let's look at the kubeconfig now. And there's a question on the chat that we should address, I think. But real quick, so if we look into this, the cluster that we're now using is this workspace KCP IO current mechanism that's coming from the plugin. And you see there's a different URL here. And that URL now means I'm talking to a different logical cluster. And logical clusters can have different API endpoints. Like they have different objects. They are logically separated on the etcd storage layer. So they have different data. And I think we're kind of, we have a couple of questions, so I want to talk about them. So first question is it essentially a cluster inside of a cluster? And I think are these V clusters? No, they're not V clusters. So V clusters spawn a lot of lightweight kube API server processes, but there are multiple processes. So there's multiple kube API servers or like a lightweight stripped down version of those running. But KCP is a single process. So add goes to KCP, it always goes to the same web server, essentially, to the same KCP process. And based on the URL, KCP knows how to serve different data. So this is a single KCP right now. So it's like much lightweighter than spawning dedicated API server processes. So when you create an empty workspace, that takes, I think, around 5 megabytes of RAM. That is all that it is. And you saw earlier that creating a new workspace takes 1 or 2 seconds. Like it's super quick to spin them up and to tear them down, much quicker than you could do with like spawning dedicated API servers. So yeah. Okay. All right. We have a couple more interesting questions, but I want to talk about this here before then we'll, I think, pick up a few more questions. One more question. Does the logical cluster has its own etcd? No, it does not. So underneath the hood, this is currently like a single etcd that is talking to, or like an etcd compatible, like a data store that is compatible with the etcd API. So it doesn't have to be etcd. And when it comes to scalability, it makes sense maybe to think about switching etcd out with something. If you're talking about like global API platforms. But under the hood, this is using a single database. That's why it's logical. Like it's, not super separated in the data layer to achieve these like performance gains, essentially. Okay, there's more question about etcd and performance. So we'll just talk about this quickly. In previous projects, we found that etcd has performance issues at scale. Since in KCP everything is a custom resource without connection to actual physical resources, how does it handle scale? So this is a pretty good question. So we're getting into advanced topics now, but I love to talk about this. So KCP has a concept called sharding. So when you find that a data layer might, reach its performance limits, or like if you have planned out for this like to be a globally distributed API platform, obviously like a single KCP instance is not going to cut it. You can scale KCP horizontally against the same etcd. That's then for high availability. But you can also start multiple KCPs with distinct etcds. And those are then shards. And every workspace that you create gets scheduled to a specific shard. But that basically means that you end up distributing your custom resources. So distributing your custom resources is possible across these various shards, and you can spin up as many shards as you want. So you can always, like, depending on the size and scale that you're working on, you can offset any like performance bottlenecks that you might be concerned about by like moving into more shards and keeping the like underlying data store of the respective shards like small and lean. One more question. Is it a reverse proxy for multiple kube API servers, or does it emulate API servers? I would say it emulates API servers. I think that would be the more description. So, okay. And there's one more question. Does all the tenants within KCP share a common data store for etcd? How are we planning to manage the HR for the etcd replicas in that case? I think this is what I tried to explain with the shards. So you can run multiple replicas of KCP pointing towards the same etcd. Then you have HA for the shard. And you can run multiple KCP instances with distinct etcds. And then you have this high availability and scalability through workspaces being scheduled to a specific shard that will then host it, and that like stretches your data across many different shards. Okay, moving on. So this is the workspace concept. So I just wanted to quickly show you a little bit of navigation. But the nice thing is that layer workspaces into workspaces, like it's a tree structure. So that means I can also create here another workspace. I call it test. I can also then use the KWS command, basically like a cd command on your command line. So basically what you can do is I can go one up. Oh, now I'm in the root workspace. I can also ask it for the tree structure underneath. So now I can see, oh, there's a root workspace. I am in that. There is the Cloud Native Live workspace. I've created that early. And within that, there's a test workspace. So I can create like very complex tree structures that mirror my organizational patterns, maybe. And with all of this, there's like one more interesting concept that we're now going to see more in Simon's part, but I just want to quickly show you this. And then we'll do like maybe 2 or 3 more minutes of questions, and then we'll go from there. So KCP also has another concept for API management. So the workspaces are the multi-tenancy aspects. But if you think about CRDs, CRDs basically do 2 things at once. Like they are a schema definition. Like you basically say, hey, this is how my API should look like. And they are registration with the API server. So when you create a CRD, new resources become available in your Kube API server immediately. KCP separates these 2 things. So what KCP does is it takes the schema definition and puts that in one type of object, into one resource. And then when you want to consume an API, you need to create a separate API binding. So I'm going to quickly show you this. So in the root workspace that I'm currently in, there is a resource called API export, and KCP dog foods the same concept. So so when I create a workspace, I create a workspace object. This is how I can query it as well. And that is part of the tenancy KCP IO API group. KCP itself distributes its own APIs via such API exports. So here, this defines what the API is like. So basically, this allows me to say, hey, I am offering an API. So now if I go into the Cloud Native Live workspace that we've created earlier, you will see that there are no API exports here. Like this is like in this workspace, no one is offering any APIs. But there's an API binding here. There are actually, in fact, multiple ones. So the API binding to the tenancy KCP.io here, we can also take a quick look at that. There's like a lot of information here. That's not the interesting part, but it tells us which kind of API objects are now available. It has a reference to an API export, the tenancy KCP.io API export in the root workspace. So now we basically reference an API that is provided by someone else, namely in this case in the root workspace. But I still am able to consume this here. So otherwise I wouldn't be able to create workspace objects here. So there's basically a clear service provider and service consumer pattern. And now you might start to see what Simon had in the slide in the beginning, why we think that this is something for developer platforms and for platform engineering. So yeah, that is kind of these are the fundamental terms. Like this is kind of like we just did kind of a glossary for KCP. So Simon, I just want to see which kind of questions we had in the chat that we can maybe wrap up in this part of the session. So one of the questions was, will you be able to use kind instead of etcd? And I believe the answer to that is yes. I know that people have tried this out with KCP. I don't know who runs it in production, but yes, since kind is providing an etcd compatible API, you can absolutely use it for this. Then the next one was using KCP, I think, allows for greater degree of customizability due to different CDs and different way, just namespace separation. Then say just a namespace. Yes, exactly. And this is the part about bindings. So basically, each work can decide which APIs it should have available through selecting the APIs through API bindings. So you're not limited by what the cluster admin decided to install as CRDs. You can select yourself what you think should be the APIs in your workspace. And every workspace has a different API surface to that. And because they all look like separate Kubernetes API endpoints, all of that is possible, essentially. And a follow-up to that was, is it possible to run two different versions of Kubernetes control plane with KCP? So KCP itself doesn't have the core resources like deployments. Pods are core resource, deployments are an apps resource, but KCP doesn't have the workload APIs, essentially. You can theoretically add it, and I guess theoretically you could try to run two different versions of the Kubernetes control plane against like emulating that in a workspace by offering different versions of the APIs. But I don't think anyone has tried that yet. I'm not sure I would recommend that. But theoretically speaking, yeah, maybe it would be an interesting experiment.
Marvin, let me interrupt. There was a question earlier in the chat that we missed, and I'm wondering if you'd like to talk about it. It was about database connections during upgrade of critical services. Can you put that on the screen, or
yeah. Let me quickly see. Yeah. Okay. Great. How do you handle database connections issue during the upgrade process? I mean, I think that's a pretty good question. So the nice thing, and this is pretty similar to Kubernetes, is of course the API control plane. The control plane goes down, the data plane usually still works. So even if you had downtime during an upgrade, hopefully like all the things that you've ordered through KCP still work. But yeah, I haven't, honestly, I've done a fair share of Kubernetes API server upgrades in my life and the KCP control plane upgrades, simply because I've been doing it time. And then I'm not sure I have ever seen connection issues to etcd, a specific part of the upgrades. One of the things that might help the person that's, well, I mean, you can run multiple shards, and then the blast radius of a database really going down or refusing to connect will be much smaller, because it will only at least affect that shard and not the whole KCP instance. I think that's all the questions we've had, and I think this is now a great time to hand it over to Simon. Is now going to show us basically in how this can work and how we can implement, shown earlier, on top of KCP.
Yeah, thanks for the handoff, Marvin. So yeah, we would like to return now to this example that we kind of want to use as to guide us through what we want to build. And to get this started, I'll quickly show a bit the things that I have already set up in advance, because this webinar can only be 1 hour long, and therefore there are some things that we did before. So you might see that Marvin, and then now you guys can see my terminal. So in case you ever get lost, because we will be using a ton of different kube configs now, is you can always refer here to the bottom of the screen. You can see which kind of persona we are at the moment and to which are we connected to. And to quickly show this to you, what we've already done is for the KCP admin persona, we've already set up KCP in its own Kubernetes cluster. And I've used the KCP Helm chart for this. There is also a KCP operator, but just to iterate this, I'm not running KCP start locally anymore as what Marvin showed, but we're actually running it inside a cluster. So to just show this quickly. Oh, great. Great when your when your demo already starts with this. So unfortunately, token's not valid. Oof, I don't want to now grab a fresh token with the demo, so you just have to trust me. I am having a Kubernetes cluster that is already running KCP. Apart from this, I also have a cluster from now I'm putting on the database provider hat. So I'm now the provider of the database, which would refer to this part here in our slide. And now I have PG native running. So PG native, for anyone who's not aware, is, oops, 1 second. So PG native, what I mean by this is cloud native PG. It is an operator that allows you to manage Postgres database clusters. You can, in this case, see this as a stand-in for any other cloud-native service. We just, for this webinar, had to pick one, but you are free to use whichever service you want. The important part is with these types of services usually is that they need to be controllable via a Kubernetes API, and usually that they share information via a Kubernetes API as well. In our specific case, what this means is if we take a look real quick, so we're in the database cluster now, we have the CNPG controller running. So this will later for us deploy Postgres. And the way this controller works is that you submit APIs like this one, the Postgres cluster API. And once you submit this to the Kubernetes cluster, it will go ahead, deploy all the pods, and it will create a secret for you that you then can use as a consumer to access the database. Now you say, okay, Simon and Marvin, that's all great, what you showed us, but how exactly does the connection work? Because at the moment, we have our isolated database cluster where the database team is working on, and we have some isolated cluster where our KCP platform is deployed on. And we're now wondering, how do these arrows, specifically this connection, work? And for these use cases, what we usually recommend to use is the KCP API sync agent. So this is a specific component that we offer for this use case for syncing between KCP and the provider clusters. And this is something that we will dive into a little bit more in depth now. First thing to notice is the API sync agent is to be installed in the provider cluster. So if we take a look again, this section here is where we are going to install the sync agent, which is what we're going to do first.
Maybe,
and in order for the sync,
maybe I can jump.
Yes,
Sorry,
go ahead,
Simon,
Marvin.
for killing your. But so what should be highlighted is that the API sync agent is a way of getting APIs into KCP. So I've basically shown you like an API platform, but it's kind of empty. Like I said, oh, there's no workload orchestration there. There are no deployments, no pods. So the question is, what kind of APIs can you then use in KCP? And that's a very valid question, actually. And we've built API sync agent basically with this separation of concern in mind. So we are saying basically, oh, there's a team, there's a service team that wants to provide like a certain service, in this case, like operating databases through the Postgres actor. But this is like one of the many ways. Like it doesn't have to be the API sync agent. We built a way to bridge Kubernetes to KCP, but you can also write your own KCP native controllers to offer APIs. Like all of that is possible. Sorry, Simon, go ahead.
Yeah. Okay. Jumping back now into the topic of how do we set up the sync agent. So the first thing that the sync agent expects is an empty API export to be there already. And this is kind of historically been built into the sync agent. So to show you this quickly, we have set this up already. So give me one. Yes. So it requires an empty API export, and as you can see, there's not much information in there, except for that it is supposed to be called databases.internal.example, and this is later some information that we just need to pass on to the sync agent. So this you can name whatever you like, whatever works for you. So important part is, and you can see in the bottom, of course, this is something that the provider needs to apply into their workspace. So we see here the workspace that we're currently at is the provider workspace, or the provider is in its own KCP workspace, and they are now applying the databases export. So we're gonna apply this, and currently it's just an empty export. It doesn't do a whole lot for us, but it is important for the sync agent. And for the sync agent, now you can see at the bottom, we're switching over to the database cluster again, because what we want to do now is to set up the sync agent. And the sync agent, for it to work, it requires two things essentially to work. It requires a kubeconfig for the database cluster where it's supposed to create objects, and it requires a kubeconfig with which it can access the KCP workspace of the provider. And this is something that you have to create as a secret. We have, I believe, already set this up. Just give me a second, guys. But basically, you can use the kubeconfig that you used for the provider, or you could create a specific kubeconfig that has limited permissions. And I believe, yeah, the secret already exists. We already prepared for this, and now we would create or we would deploy the sync agent. And for you to show this, so the sync agent typically is deployed via Helm. And I want to quickly show the Helm values that we are using. And you can see it is very straightforward. It takes in the API export it's supposed to sync, and it takes in what the secret is called with the kubeconfig for KCP. So that was the secret that we just created. And with that in case, so here's the Helm upgrade command. So we're just gonna install the KCP sync agent for now using the values file that I just showed. So let's get that going. I'm not sure if we already have questions. Unfortunately, I cannot see the questions, Marvin, so feel free to interrupt me also when there are questions relevant to the topic at hand, because I cannot see the chat, unfortunately.
Yes, there's one question. Can provider team attach custom controller to KCP instead on per workspace basis?
So let me just quickly read this. Give me a second. Custom. Depends, I think, a little bit on what you mean by 2KCP. So in general, a controller would map to one workspace in KCP. So it would attach to one workspace. There are concepts in KCP which we do not want, I think, to show with, or which are not out of the scope of this webinar, to also bundle workspaces so that you have like an abstraction layer that breaks the multi-tenancy. This is called virtual workspace, but I think this would go beyond the scope of today's CNL. If we have some time left at the end, my offer would be that we dive into this a little bit. But in general, one controller would map to one workspace. Okay. With this, I think our sync agent is now installed. And by default, that sync agent is not doing a lot at the moment because it needs to be configured. And for configuring the sync agent, what we have available is what's referred to as a published resource. So if we take a look at a published resource, and this is basically where the majority of the configuration happens. So what we can see in the published resource first and foremost is the object that the sync agent is looking for in KCP that it's supposed to sync back into our database provider cluster. So that's the first part of it. The second part that we then have is how should it rename the object. And this, in our case, we just give it the same name as upstream. And the reason for this is because our objects are already namespaced. So the cluster Postgres is namespaced. And the default configuration for the sync agent is that it will create a unique namespace that maps to a single KCP workspace. And by default, the sync agent ensures this for you. We will see in a minute how it does that exactly. It's not a random string it uses for the namespace, but for now, the important part is why we need the renaming is because it's perfectly fine for KCP workspaces to have the same namespace and the same named object. But of course, on our Kubernetes cluster side, we need to make sure that they are different. And this is what the renaming does. The other part that we have, and this is what's referred to as a related resource that we can see here in line 12, is we have the ability with the KCP sync agent to sync objects back into KCP. And why do we want to do this? If we return to our use case here, one of the important parts is that we want to sync the credentials for the database back from this cluster where they get created into the tenant of the user so that the user can directly fetch the credentials from there and they never have to interact with the database cluster at all. And this is exactly what we're doing here. So essentially what we're telling it is, hey, look for a secret that has the following label, and the label is something that we control through the syncing. And this is something that's built into basically PG native itself, but PG native will set the label to whatever name that you gave the cluster object. And in our case, we just say, okay, look for a secret that has this label and then sync it back to KCP so it gets access. And here again, the default is it will sync it back into the same namespace of the workspace in KCP where the object was initially created. Of course, we're just scratching the surface here. There are endless possibilities of both renaming and identifying and syncing back related objects. We do think that this is kind of a sane starting point, but of course, for more complex installations, you could have additional logic and you can have additional related objects. As you can see, related objects is a list of objects, so we could sync back multiple objects if we want to. That being said, let's apply what we just saw. So we're creating the published resource that worked nicely. So now we have set up the API sync agent to watch for new databases to be created anywhere in, for new database clusters to be created anywhere within KCP and sync them back into our provider cluster. Now, the last part that is missing for us is to actually create these databases as a consumer. And for this, I'm now hopping into the fourth, and I promise last different kube config that we're looking at. So we can see we are in a different workspace. We're in the root consumer workspace. And of course, in this workspace, currently, we do not have the cluster available. So you can see there's logical clusters and cluster role bindings and cluster roles, because cluster is a term used a lot in Kubernetes, but you can clearly see there are no PG native clusters yet, because that API doesn't exist. And this all comes back to what Marvin mentioned, and that is that you need a matching API binding and API export for an API to become available in the consumer workspace. And this is exactly what we are doing now. So let's take a look into what these API bindings look like. And so this is what the API binding looks like. And the first important part to look at is right here. So this is a reference to the API export. And you can see, again, we're using here in the path, we're using this workspace pathing that Marvin showed. So we're looking basically for an API export in the root provider workspace that is called databases.internal.example, which was the name that we gave it. By doing this, the API sync agent already gets access to the database cluster objects, as these are part of the export. However, we also need to have access to some additional resources, namely, for example, the secrets, because we want to sync a secret back. And for this, currently, we also have to set up additional permission claims, and we also have to accept these permission claims. So API binding and API export always work in conjunction, and essentially these are the required permissions. I think at this point, I do have to say, because I think this will come up as a question, is we are currently working on making this a bit more fine-grained, so that you can fully select what type of objects you should have what access to. For the simplicity in the demo and the current state, it matches the verb star, so it matches, and then it matches also all selectors at the moment. With this being said, let's apply the API binding. Oops, I'm missing one second. And now what we expect to see is that the API resource is now available. And we can see here in the middle, we can see the Postgres cnpg.io API is now available. And that's the API that the database team wanted to share with the consumer. And now by having this API available, what we can now do is, of course, create an object of it. So if we take a look at one of these objects, it looks like this. So you can see this is exactly the API that we wanted to share. And then there is some data on it of the API. So it's like an instance one and the size of 5 GB of the storage. But as mentioned at the beginning of this presentation, Postgres CNPG really is just a stand-in here. It could be any other API with all of its custom fields. And of course, they get validated. Like with CRDs, you can specify fields, you can specify validation for the field, and it's the same in here. So let's then create our database by just applying it into our consumer workspace. And what's happening now is this object is being synced back to the database cluster. So let's go into the database cluster and actually have a look at it. So what we can see now is that there is, oh, we cannot see a lot. I guess, yes. So I think we're going into debugging mode for a second. So what we expected to see was a newly created namespace that has a unique name. But this is not happening at the moment. All right, that is the crux of live demos. So let's dive in.
You forgot airbag. Let me spoil this for everyone for the API sync agent.
I'm very sorry. Then I know what to do. Okay. So one thing that, of course, we also need is the API sync agent needs to be able to create the objects inside the cluster, and this is done via normal airbag. And I guess this is what I've missed. So let's take a look at this real quick. And basically, this is just give it on Postgres the permission to get, list, watch, create, and update and delete. And it's a standard cluster role and cluster role binding. And it needs to be done in the provider cluster. So let me just quickly apply this. It's good that we're 2 people and 1 person can live debug. Okay, and now, fingers crossed. Am I too impatient now is a good question, or we need to hop into it and debug it. So let's take a look. It's just starting up. Okay, maybe I was just too impatient. Yes, we can see now. I was just too impatient. So we can see here in the bottom, we have a namespace with a very cryptic name, but this is, it uniquely maps into KCP. And now if we look into this namespace, so if we do k get clusters -n and then of this namespace, we can see that this got synced over. And now we just need to wait. It takes a minute for the database to be ready. So we're spinning up a new pod and so on. But I think the important part here was to first show this gets synced over. And we can now see it's 1 instance and it's ready. Cluster is in a healthy state. So this part of the syncing already worked and was demonstrated. Now what we can also see in this namespace is, and this is something that the Postgres operator created, is there is a secret for the consumer. And what we now expect, of course, is that this secret gets synced back. And let's have a look. Fingers crossed, everyone. Yes. Oh, wait, this is 4 days old. Did we maybe forget to clean this up, Marvin? I guess.
I think so. But yeah, what we're basically seeing here is, well, this is updated by the API sync agent. The data synced back to KCP. So now the consumer has access to this data that we cluster.
Perfect. And with this, we have handled the full life cycle of this. So this is essentially what we shown, including the sync back. And you can see the consumer always stays within their tenant. And also the database team, they stay with their tenant. Yes, they access objects from the tenant and they push objects into this, but within a built-in functionality in KCP. And of course, these tenants are otherwise isolated from each other. This would conclude everything that I wanted to show. Luckily, we made everything work. And I think we would now open the round, the larger round for questions.
There was one here, if the provider is not a Kate's. Here, I'll put it on the screen here for you.
Yeah, so if the provider is not a Kubernetes resource such as CNGPG does, KCP support it. Such if platform team wants to expose database managed services in a cloud VM creation API to be available to consumers. Yes, so KCP is built on top of Kubernetes, and as such, there is the requirement to be a Kubernetes resource API. Of course, what is possible is to use something like Crossplane that would handle the in-between part for you. Like many Crossplane providers, I think, work based on that promise where they take in a Kubernetes resource and then they do some API requests. Yeah.
Here's another one.
Yeah. Is it possible to apply kind of quota from a producer point of view? For example, one database per consumer. How does admission validation feedback in producer side is returned? So I would hand this over to Marvin because I don't know if we have quota built in.
Yeah, so I think we do have the quota, the resource quota from Kubernetes in. I'm not sure if that is active or not. But that is within a workspace. But if you want to impose quotas on workspace, then you would basically need to do, like admission is mentioned. So you would need to do an admission webhook essentially. That is currently not part of API Sync Agent because that's more like on the KCP's like side of things. But you can have custom admission webhooks for objects that have been created for APIs coming from API export. That you could basically do these kind of quota limiting. Like it's not a feature built into KCP yet, but it probably will be at some point.
Okay. Do we have any more questions?
No more questions. There was just one follow-up to that from Christoph, but I don't see any more questions coming in. Well, I think that might be a wrap here, gentlemen. Thank you so much, Marvin, Zeman. Very enlightening. I hope our guests today were able to learn a few things they can bring back to their jobs and maybe their hobbies as well. Is there anything else you'd like to say before we end the stream?
Just find the project at kcp.io. And yeah, thanks all for attending.
Yeah, thank you guys for doing. Thank you for asking all the questions. At the beginning we weren't sure if we would fill the 1 hour, but with all of your questions, that was amazing. That was a ton of fun for interaction.
We do have one that just jumped in. Sorry, Zima. Let's do that last one, then we'll wrap.
Yes, that's a very good question. How does a pod in the consumer cluster connect to Postgres? So there's, I think, two sides to this question. The first part is it is up to the provider to how to manage this part. So it certainly is possible to provide other objects or to sync other objects over. It's also, for example, possible to have an ingress at the database cluster to directly connect to the Postgres server. One thing, and this unfortunately would be too large for this talk, is there is also the way to use tools like Crow or cross-plane compositions to provide higher level APIs. So what you could do essentially is you could use Crow or cross-plane compositions to create the associated objects that you want, and then tell Sync Agent only to sync these back up, which is a common pattern that we're now seeing.
Very good. Well, thank you so much. We're a little bit over time, so I'm going to end the stream here. Marvin and Zeman, if you want to hang on just a moment after this stream is ended, we'll wrap up. And thank you, everybody, for tuning in and listening. Have a great day.